yeah, we've got John that's going to be talking about designing accessible interactions for the immersive web. So
take it away.
Yeah.
All right, cool. Hello, everyone. Let's see. I've got my screen being shared, I think, but I'm not seeing it pop up. I don't know if I have any control over that. But while I'm trying to figure out how that's happening, just to give an introduction by myself, I am the Director of Research and Education for the University of Washington Reality Lab. My work is mainly about working with our undergraduate research program as well as our educational efforts. So our curriculums as well as our outreach efforts. I've done a number of workshops actually in WebXR before, both within our own university as well as abroad. Looks like I've got my screen share working now. So let's kind of talk a little bit more about it. So yeah, we are a research center within the School of Computer Science and Engineering at the University of Washington. We are at the intersection of computer vision, graphics, human-computer interaction, basically everything pertaining to virtual and augmented reality. And so one thing I just want to give a shout out about, I won't play these videos, but I'll try to share this slide deck afterwards, is we had this capstone last year, actually. We offer it every year where we have students work in teams of 4 on projects over 10 weeks to create their own virtual and augmented reality applications, oftentimes really having very little experience going into it. Last year was the first time we actually offered it entirely in WebXR. So we had 7 teams create these amazing applications in WebXR. If you go to that link or you check it out later on, you can see some of these applications, you can try some of them out on your own. But I want to talk about one of our capstone projects from a couple of years before that, actually. And this was a team of students that was interested in exploring, what would it be like to simulate using a wheelchair in virtual reality? And so what you're seeing here is a prototype they created where they took an Acer headset, they attached a Leap Motion headset to the top of it, they actually super glued it to the headset for hand tracking. And then in the left corner, you can see this rig that they've created, which is they actually took a regular chair and they bolted some bike wheels onto it, and then with a kind of a ragtag construction of duct tape and cardboard, they actually created holsters on the sides for the controllers. And so the gyroscope and accelerometer data was being captured, so the rotation was being noticed even when the headset couldn't track the controllers properly. And with all of this combined, they were able to create this application where you were, in essence, using a wheelchair in virtual reality. And so in this case, right, this application was meant as a tool for empathy more than anything else. It was meant for people to understand, what is it like to try to actually use a wheelchair in the world? So it presents some challenges like trying to navigate a really cluttered space full of furniture. How do you get to the bathroom? How do you use an elevator? What's it like to have to try to turn around in the space? Of course, the team experienced a myriad of complications, especially in the area of motion sickness and trying to work around that, and the smoothing that was required with all of that. Kept tuning it, never quite got there because, again, it's only 10 weeks. But it was one of those initial ideas of inspiring, like, what other approaches can you have to interacting in virtual reality? And just kind of one idea for it. But again, it's not, it wasn't a tool for accessibility. It was something to let people understand a bit more about, it's a tool for empathy, to understand what it's like for somebody in this position in the real world. But when you think about, or when you really learn about what people with motor disabilities or with other impairments, right? And disabilities can be permanent or temporary, even, right? When you break your leg, even, that's something that limits you for a while. The way that they interact with technology is different. They often can't use the conventional devices, the mouse and keyboard input, or especially in virtual augmented reality, the way that headsets and hand controllers work is extremely limiting for a very broad audience. What you see often, right, is these types of switches that get used. So I've had kind of a sample here of different inputs that people have in their own homes. So things like buttons, proximity sensors, grips. A wobble switch, which basically can recognize any different movement in any direction. On the bottom right is a sip and puff, so it's based off of using your mouth to actually pass air through a tube to recognize that as a sensory input. But it's not, one thing to understand about this space is that it's not standardized. A lot of these different devices operate through a 3.5 millimeter jack, and that's something that we've, probably the closest thing we have to a standard in the space in terms of these different input systems. But there's also an even broader array beyond this, right? There's some cases where people have eye tracking. There's some people where people actually use voice recognition to interact with systems. And that's kind of really one of the biggest takeaways when you think about how do people with different disabilities interact with technology. And the answer is that it's kind of an open world. You have this full customization. Everyone has their own setup for how they do things. Um, and I think one place that I really kind of want to point out where this was acknowledged well was in the Xbox Adaptive Controller. And so, as you see on the bottom here, this entire line maps every single input on a standard Xbox controller to a 3.5 millimeter jack. So you can have all these different switches hook into it in any way that you want. And this is one of the first places I've seen where it's really enabled this level of customization for the input systems that people have. Um, and so, as this pertains to augmented virtual reality, is then thinking about um, the way that you think about using a standard headset, right? So, what we started to do a couple of years ago, this was actually my research work doing my master's degree, was looking at what are the ways that people really use virtual and augmented reality? What does it actually take to interact in this space? And we started to build out this taxonomy of what is it, what are the actual, when you look at it and synthesize it, what are the inputs that people use and think about those interactions versus the inputs required to do them. And so I'll talk about a couple of these kind of the real standard basic ones. We did an analysis of about 20 different WebXR applications a couple of years ago and looked at, what were the actual intents behind the interactions that they had in them and what was actually required to use them, not thinking about just the fact that you put on a headset and held some hand controllers. The first one, of course, is really just thinking about this 6 degrees of freedom control, right? So rotation and positional control, and the inputs required to do that. And so thinking back on switches, oftentimes switches are binary inputs. It's either on or off, right? You're either pressing a button or you're not. And so we tried to synthesize all of these interactions into those specific ideas. And so if you think about like rotation and position are both things that are kind of they're pretty core, right, to virtual and augmented reality interactions. And so when you think about both of them, they have these 3 axes they have to control on. In this case, you don't really have to control roll in the rotational axis, right? So like you're not tilting your head side to side unless you actually want to do that. That's one of the big taboos of preventing motion sickness in the space. So you really have kind of 10 binary inputs here just to control your position and rotation. And you could boil this down even more if you wanted to into a way of having it so it's one input to change which axis you're manipulating, and then another input to maneuver through that. But this is really kind of the core to enable any WebXR application to function well in terms of control. On top of that, we also have the targeting aspect of it. So one of the most ubiquitous things you see is that you have to actually target objects in your space. And there's a myriad ways to do this, right? Center field of view is probably one of the most often that you see, especially with, mobile versions, mobile applications, 3 degrees of freedom based applications. But you also see mouse clicking sometimes if you're doing it through desktop view, or using your hand controllers to actually point at something. Or it's actually just the spatial position of the hand itself, right? And that's what that means to say is you actually reach over and grab an object in your space, right? Which requires moving your perspective over there so that your hand controller is in proximity. And these are all just different ways to target an object, right? But this is thinking about interactions again. The real intent behind this is that you're just trying to target a specific object. And so that's what we were doing in our research, was seeing these are the ways to accomplish this as your input. But what are you actually trying to accomplish with it? What is the intent? And that is just targeting. And what that ultimately requires is a single input, right? If you know the objects in the scene, you can use a single input to iterate through all of them to target them separately. Likewise with this is selection of objects. And this one's kind of more of a general interaction. But this is thinking about the way that there's generally something else you want to do with an object when you have it targeted or when you have it focused, right? That could be picking it up, which is when you think about it, really just a single input, and now you're moving it. Or you want to have the object do something, right? You want to change the color of something. You want to select something. This is just kind of this catch-all input that we have here as an idea. In other instances of our work, we've kind of referred to this as like the interact option. This is like you want to interact with your object. That is a single binary input to accomplish that. And so that's kind of when you think about it, that's 12 binary inputs right there, right? That's the movement, rotation, targeting, and selection. And that's really kind of the essence of most XR applications. But maybe you want to get more complicated, right? Maybe you want to have things like you want to utilize hand tracking. Maybe you want to do things like actually have gestures. So the movement of your controllers, the movement of your head or your body. Or maybe you want to have simultaneous inputs, right? Like I think a very easy example is like a bow and arrow, right? Where you have to use multiple hands at the same time. And that's fine. And you can include these things. But when you're thinking it from an accessibility mindset, um, it's really important to just bear in mind that not everyone can do these things, right? It's to design for a single specific input system is extremely limiting for everything else. And so when you add these in, right, you can do that, but just make sure it's not a requirement of your application. Think about the intent behind what someone's doing, right? If someone needs to hold a bow and an arrow to actually fire an arrow off, the intent there, right, is to actually ultimately have the arrow be fired. And so that's something where you can think about what is the interaction happening and what is the input required to do it. And that's where the input, right, to fire an arrow could be literally a single input versus the entire action of taking your hands with two different objects in a virtual space and pulling one across the other. And so what we ended up doing was creating this prototype called Flexor, where we created a component for A-frame that could be integrated with applications to enable this full 6 degrees of freedom control. This was done a couple years ago through the Gamepad API, but it's changed a little bit now in terms of the technology. And we built it for WebXR because of the adaptability of it, the ability that you can take an application, even when it's already running in the browser, right? And you can add a component into it in real time to enable this type of control. And that's what Flexor was designed to do. So you could go into any A-frame application, and if you kind of played with the code a little bit, you could add in this component and then have 6 degrees of freedom control, even if it wasn't built into the application itself. On top of that, you could also have this full targeting selection with just a little bit of developer support as well, just through tweaks in the code base by adding the component to the specific objects that you want to have controlled. And so I think I'm running a little short on time here, but I want to show just kind of a brief demo of this in action. So this was actually an application created by a developer named Jorge Fuentes. And it was just a 3 degrees of freedom application of this little Halloween town. I know it's seasonally very accurate, but we just found this application. It's a fantastic little one where you just look around an environment and point out the different highlighted spots. And so what we ended up doing was we just took our component and dropped it in. And so now you see the controller inputs on the sides enabling this full interaction of this space. And so I think I'm running near the end of time. I have another demo here that I'll kind of play out as we're wrapping up. This is just demonstrating what it would be like to actually have control of other objects in a scene. So currently you're controlling the player, and then you can use another input to switch your control, your targeting to another object, and then decide whether those objects can be manipulated or not. So if you wanted to move objects around an environment or target them, you could do all of that without requiring the accuracy of actually having to look at them or get near them. So I think with that said, that's everything I wanted to talk about today. The last thing I want to do is just kind of throw some of the resources out there. I'll post the slide deck, I think, in chat afterwards. People can see this. Just a shout out to some other resources out there. I'm also part of XR Access, so I want to promote them and their working groups and the research they're doing also.
Awesome. Thank you so much, John. That was a really great tour of a lot of the work that you've been doing in the realm of accessibility. And the thing that it reminds me of is that when you look at things from an accessible perspective, it sort of allows you to reevaluate the underlying mechanics and techniques of the affordances of the medium and how to kind of gracefully degrade it. So I love that you're sort of looking at what's already been happening in the 2D realm and starting to translate some of these other ideas. So thank you so much for all the work that you're doing there with your research and the work with XR Access. I highly recommend folks check out the conference that XR Access had recently as well, if you want more information. And yeah, look forward to seeing the links that you post so people can dig in more.